Hello, this is Gary King. I'm going to be presenting Group 6's Chapter 16 presentation on enabling feedback so development and operations can safely deploy code. And this is in collaboration with Oluwade Ferdin. So to begin with our table of contents, we're going to go over an introduction, then the use of telemetry to make deployment safer, and how Dev shares that pager rotation duties with ops, have developers follow work downstream, have developers initially self-manage their production, and then a conclusion. So to introduce this, we're going to enable feedback so that our development and operations can safely deploy code. That's the goal. We want to be able to have that code deploy safely and so that we can keep our systems up and running and keep everyone happy as a result. By providing that faster, more frequent feedback to the engineers, those developers who are performing the deployments, whether that is dev or ops who's doing the deployment, as well as reducing the batch size of their work. We want to have smaller deployments, smaller batches, create safety and then confidence in those deployments. And then so that we can integrate testing groups and deployment functions into one group with responsibilities, responsivities, and goals. All right, so to use telemetry to make deployment safer, we need to ensure that we are actively monitoring our production telemetry. We have to have that telemetry set up. We have to be watching it on an active basis so that we can see if anything goes down. A lot of companies have 24-hour telemetry. They're actively watching things 24 hours a day, 7 days a week, 365 days a year. You need to be watching it very actively like that. I know in the company I work for, for certain pieces of telemetry that we need to know if this kind of problem happens, we need to know right away. We've set up email alerts and so that we get immediate notification of them and we can go in and address them right away. For errors that can be cached in the deployment pipeline before they get into production, that's the goal. We can do some testing before and catch them there. I know that's something my company does. We do some rigorous testing before we deploy something. With some of our vendor partners who push software to us, we have to go through and we test for weeks. We pay people to test to make sure that software isn't going to cause problems in production, because if it does, it costs us a lot of money. So we have to make sure that that's stable going forward. Fixing forward can be extremely safe if testing is automated and fast deployment processes are in place. So we got to be able to fix going forward. So that helps us out a lot. So this is a graph of how this telemetry helps us to solve these problems. This image shows a PHP code deployment at Etsy that was generating a spike in PHP runtimes. You can see the deployment and right away and immediately spike in the wait times, and then you'll notice there's a fix and it doesn't drop off right away, but very soon after you see that drop and things normalize. The developer quickly noticed those problems. They quickly generate a fix. I mean, you had like 8 minutes there and they had a fix, and then they got the issue solved. That's the kind of fast fixing forward and rapid deployments that you want to be able to have and have everyone on the same page, so that when ops notices a problem, dev is jumping right on that. That's where that DevOps really comes in. To help with that, we want dev to share that pager rotation duties with ops. So what that means is when oftentimes, like I was sharing in my company, we get email alerts when certain things happens. So to integrate development, and with that, what we would do is we'd say, okay, someone in development's gonna carry the rotation. They're going to get the alerts and they're going to have to cover any problems that happen in this time. But what that does is that allows everyone in the value stream to share in the downstream responsibilities. Dev can't just kind of push it off like, oh, I just write the code, I don't take care of it. Now with sharing this pager rotation, they have to service it and say, okay, actually the code I do write has an impact on someone else, and I do need to service them, maybe not all the time, but now it makes a whole different meaning to them, what they're writing. Putting developers and development managers and architectures on those page rotations, that's what's got to be done. This feature is only done when it is performing as designed in the production. You need to make the market orientation team responsible for developing the feature and running it in production. So we need to have the developers follow work downstream. This is going to be critical so that they can understand how the changes they make in their code will affect the end users. They need to understand what the end users are using it for, so they can get a sense of, okay, what will make their lives easier, what will make a better product, instead of just, oh, this might be an interesting feature, but it really has no basis and may even make things more difficult for the users. So to do that, we're going to, some of the instances that were shared in the book talked about how requiring scores of clicks to perform simple tasks. If you track how many clicks it takes to do something, that might make them go, oh, shoot, well, I thought this would be an easy process. It takes me, a minute to do. But now I just realized, even though it's only a minute, it's like 200 clicks. I'm clicking, click, 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 click. And that's frustrating for a user. Cutting and fastening text from multiple screens or writing down notes on paper. These are things that you got to take care of and look for. You need to observe how our work affects our internal customers. That's ultimately the end goal of this developer, or to have the developers follow the work downstream, as we want to make sure that they have an understanding of what happens after it leaves their purview. It's so common in any kind of job to just think about your little niche, and this is what you do. If you're a developer, right, you develop code. And so you don't think about what that code actually does, but we need to have a more holistic mentality where we can see what happens, and this goes for ops too. We need to know what it requires of dev to develop and to write this code, and we need to have an understanding of when we're making requests and things that we want, okay, this is how difficult it's going to be to write, or maybe this isn't even something that can be done with what we have right now. But also on the flip side of that, dev needs to know, when I write this is the effect it has. That when I make these changes, these are the effects it has. And so I need to be more cautious when I do that. Have developers initially self-manage their production. So operations can experience disastrous production releases at any time. This is very true. To prevent this, we can define launch requirements that must meet and be exposed to real-time production traffic. We need to do this to defect counts and severity, get an idea of what that would be like. The type and frequency of the page alerts. This will help us in developing better telemetry. We want to get page alerts and things that are important, that are really going to make a difference to the end user, but we want to also limit our telemetry on maybe minor things, the things that we might have alerts going off of, but don't make a real difference to the end user. We might want to turn that down so we're not, bombarded by extra alerts that we don't need. Monitor the coverage, check the system architecture, the deployment process, and the production hygiene. Looking into all those things to make sure that we have a good, healthy deployment here. And as this graph shows, you can see what happens from the HRR to that handoff, and you can see how those service times can drop dramatically, and so maybe you need to hand back off. And so you're just watching that, as stability drops, maybe it's time to have to hand off back to ops. Maybe they're better at handling those end users and getting those taken care of. Who knows? Just depends on how you want to manage that. So in conclusion, this presentation covered the feedback mechanisms that enables us to improve our service at every stage of our daily work. When we create a feedback loops, we make production deployment safer, we increase the production readiness of our code, we create a better working relationship between development and operations. And we talk about how telemetry can enable the hypothesis-driven deployment. Thank you so much, and hope you enjoy this presentation.